Okay, so I had to draw this picture because it was really confusing to try to draw it all at once. But this is what we call the unit circle. This is how we first start talking about trig functions. Let me point out a few things here. If you look, the circle only goes with a radius of 1 in every direction. Okay, so at the top, which is 90 degrees, we have our pi over 2, 180 is pi, 270 is 3 pi over 2, and then we're back over to pi over 2 for 360 degrees. Okay, so what we're going to talk about is if we have an angle, x radians, and I have it drawn there, we're going to talk about the trig function. Now we can use the trig functions for a lot of different things, but right now all we're going to talk about is what are the trig functions, and then we're going to show applications of the trig functions. So we'll start with the unit circle here. So as you can see, we have a little right triangle drawn right here, with side lengths A, B, and 1. Okay, so if it's a right triangle, if we use the Pythagorean theorem, that's going to be a squared plus b squared equals 1 squared, or just a squared plus b squared equals 1. Okay, so with our trig functions, we can only use trig functions on right triangles. And so x is going to be our degree here. So we're going to say what is the different trig functions of that degree. So we're going to use this guy to kind of describe how to do that. And this is going to be true as we go all the way around the circle. Okay, so our first trig function is sine, then we have cosine, and then tangent. Those are our main three. So let's first start with sine of x. Using this way, and again, that angle can move all the way around the circle, and this AB is just going to be a point on that circle. It is always going to be just B. Cosine of x is going to be A. Tangent of x is going to be B over A. Okay? Then we have secant. Now let's write it like this. Let's write cosecant, secant, and cotangent. Now these are not the inverse of these, but the solution you get is actually the reciprocal of each of these. Cosecant is the reciprocal of x, so you get 1 over b. Secant is the reciprocal of cosine, that's 1 over a. Then cotangent of x is a over b. Now let me point out something here. Obviously a cannot equal 0 here, and b cannot equal 0 here. So if you go back and look, when does a equal 0? A equals 0 at pi over 2 and 3 pi over 2. So you know that tangent of pi over 2 is undefined, because you can't have 0. Just like on the other one, b can't equal 0. For cotan, that's going to be here and here. Okay, so cotan of pi or 2 pi or anything like that is going to be undefined. Any multiple of just pi. Okay, so I'm going to use the same unit circle, but I'm going to change it to where we go out to r, just radius in any direction. So at pi over 2 we're at 0r, here we're at r0, here we're at negative r0, and here we're at 0, negative r. So if I have some angle x, okay, and I'm at AB, this is R, this is A, and this is B. So instead of using 1 for that R, if you look at our trig functions again, we now have sine of x is B over R, cosine of x is A over R, tangent is still going to be B over A, cosecant is, of x is r over b. Secant is r over a. And cotan is still a over b. Okay, so let's kind of break this down. If we have a triangle, here's x, here's your a, here's your b, here's your r. You got to have some way to kind of remember your trig functions, and the way I remember them is SOHCAHTOA. Okay, a lot of people say it's like an Indian chief SOHCAHTOA, or a Polynesian proverb, whatever. They just remember SOHCAHTOA. SOHCAHTOA stands for sine is opposite. I need to write that prettier. Sine is opposite over the hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. And that's how to remember it. And then all the other ones, cosecant goes with sine, secant goes with cosine, and cotan goes with tan. You just flip each of those. Okay? So here's our triangle. If you look at that, you can see that if our angle is x, sine is opposite over hypotenuse, which is b over r, which is what we just found. Cosine is adjacent. The adjacent side is a, so that's a over r. Tangent is opposite over adjacent, which is b over a. And then just for each of those, you can just flip them. Cosecant's r over b. There should be an x on all of these. Sorry. Secant of x is r over a, and then cotangent of x is a over b. Okay, let me also point out here that if you use the Pythagorean theorem, a squared plus b squared equals r squared. And going back to this page, if you were given just this point, you could find r by using that formula. Okay, because it's just a right triangle in there. Okay, so let's find all the trig functions given the point 3, 5, negative 4, 5. Now that is that point on the graph. Let's see 3/5 and negative 4/5. So we're down here. Okay, so here's your x. Well, you can think about just dropping a thing down like that and you get a triangle. Now I know negative distances don't make sense, but in this case we're just going to use it as a side length, so it makes sense. So here's the point 3/5, negative 4/5. Okay, so let's first find r. R is going to be 3/5 squared plus negative 4/5 squared, which gives you 9, this is r squared, 9/25 plus 16/25, which that means r squared is 25/25, which if you square root that, r is just 1. Okay, so then we know that a is 3/5, 3/5, b is negative 4/5, and r is 1. So if we want to find sine of x, it is, looking at this triangle, 1, a was 3/5, negative 4/5. Okay, here's your x. Sine is opposite over hypotenuse, which is negative 4/5 over 1, which is just negative 4/5. Cosine of x is adjacent over 1, which is just that. Tangent is, is opposite over adjacent, which simplifies to just negative 4/3. And then for each of the other ones, we got cosecant, we'll just flip the top one, negative 5/4. Secant is 5/3, and then cotangent is of x is negative 3/4. Okay, let's do another example. Let's try to find all the 6 trig functions for the for an angle x with a terminal side at the point negative 12/13 and 5/13. Okay, now this is your angle x, but we can use this as our x and make that as the right triangle we're going to use. So that would mean that this lower side is negative 12/13 and this is 5/13. Okay, if we go to find our r, that's going to be just the square root of negative 12/13 squared plus 5/13 squared, which is the square root of 144 over 169 plus 25 over 169, which is the square root of 169 over 169, or just 1. Okay, so here's our triangle, negative 12/13, 5/13, and then your r is 1. Okay, so then sine of x, here's your x, is going to be the opposite over adjacent, which is just 5/13. Cosine is, over hypotenuse on the top one is adjacent over hypotenuse, or just negative 12/13. And then tangent is opposite 5/13 over negative 12/13, which simplifies to negative 5/12. Find the other trig functions. Just flip each of those other ones. So we have 13/5, negative 13/12, and 12/5. Negative 12/5. Okay? So there's how you do that. Okay? Now when you graph these, well, we'll do let me have another section with how to graph functions.